For us modern humans who always claim to be so technologically advanced, those humans from the past might seem super primitive. I mean, the huge technological gap between us is so big that it's almost like we're a whole new species, and just a few hundred years were enough to create this gap. We think that since human curiosity knows no bounds, our intellectual progress should have no limits either. But the truth is, when we look at it from a galactic scale, our progress is actually pretty insignificant. So, how advanced can the human race become? And how long will it take us to reach a super advanced level? Do those huge cosmic voids hint at the existence of super-intelligent alien life? And just how advanced could those alien civilizations be? Well, get ready to find out the answers to these questions. We've already created the internet, landed on the moon, and discovered the Higgs boson. Our spacecraft have even entered interstellar space. In the past 100 years, it seems like we've accomplished feats that were beyond imagination. And it's hard to imagine that we could go even further. But what if all that we've achieved is just the tip of the iceberg? What if all of human progress is just some kind of collective illusion? Over time, the Kardashev scale for the technological progress of human civilization has been expanded and refined. This theory divides the technological level of civilizations into 4 grades. Grade 1 civilization, also known as a planetary civilization, can make use of all the energy resources on its planet. Grade 2 civilization, also called a stellar civilization, can go further and utilize the energy of an entire star. Basically, it can control a whole planetary system. Grade 3 civilization, known as a galactic civilization, can tap into the energy resources of the entire Milky Way. They can move planets around and even use stars to feed black holes. Grade 4 civilization can even create a whole universe. According to this theory, humans haven't yet reached the standard of a Grade 1 civilization, but we've already surpassed the stage of a Grade 0 civilization. So, which stage are we really at? In this grading system, Grade 0 represents a specific amount of energy consumption by a civilization, which is about 1 megawatt of power per year. Right now, our average annual energy consumption is around 17.7 terawatts. And just 1 terawatt is enough to light up 10 billion 100-watt light bulbs at the same time. Currently, humans score about 0.73 on the Kardashev scale. So, how long will it take us to reach a Grade 1 civilization? A famous theoretical physicist estimated that if our annual energy consumption growth rate is 3%, it'll take about 100 to 200 years for us to reach a Grade 1 civilization. Right now, about 1/100,000 of the sun's energy reaches the Earth. And we're only using 1/100,000 of that solar energy. Once we reach this stage, we'll be able to use all the solar, wind, and tidal energy. We could even control weather conditions, change the paths of earthquakes and volcanoes, and even build cities that float on water. Even though it sounds like we'd have superpowers, compared to the abilities of a Grade 2 civilization, these powers are pretty small potatoes. Grade 2 civilization, also known as a stellar civilization, can break free from the dependence on its home planet and control the energy output of an entire star. One way to do this is by using a giant structure called a Dyson sphere. A simple version, like the Dyson ring, consists of a series of solar collectors that orbit around a star. For example, a Dyson ring could orbit around the Sun at a distance of about 160 million kilometers. As technology keeps advancing, more rings will be added to this structure, each with its own orbit. Eventually, this giant structure will be like a shell that wraps around the star, absorbing most of the light energy and collecting almost all of the star's energy. Another method is called stellar mining. This technology might be used by a civilization that's approaching the mid-level of a Grade 3 civilization. It can extract matter from a star and send it into the rotating area near a black hole. The ergosphere of a black hole, which is a region outside the event horizon, is where a lot of interesting phenomena happen. By sending matter into this area around the black hole, energy can be obtained with higher efficiency. This is called the Penrose process, and it's estimated that about 29% of the black hole's energy can be extracted. However, there's a downside to this method. The rotation speed of the black hole will gradually slow down and eventually stop. But this also opens up another possibility, which is to use the Hawking radiation released by evaporating black holes. This technology is way beyond our capabilities. But for a Grade 3 civilization, it might be as common as ABC. Grade 3 civilization, the galactic civilization, will use similar technologies as the previous grade, but on a much larger scale. We're talking about galactic-level technologies here. The whole Milky Way will be filled with Dyson spheres around billions of stars. New planetary systems will be artificially created, and their energy supply will be unlimited. These civilizations will be almost immortal, and the only thing that could threaten their existence might be sudden natural disasters, like a huge supernova explosion. For humans to become this advanced, it'll take at least 100,000 years, maybe even 1,000,000 years, provided that we can survive that long. But do such civilizations really exist? If they do, their intense technological activities should be easily observable in space. According to NASA's data, in the past 20 years, we've discovered about 4,000 exoplanets. And just in the Milky Way alone, there could be trillions of stars and their accompanying planets. So, why haven't we found any signs of them? This is the so-called Fermi paradox. It points out that our universe is so old and vast that logically speaking, there can't be life only on Earth. But for decades, we haven't found anything similar. Maybe we just haven't been looking hard enough. Right now, our search for extraterrestrial intelligence is limited to capturing radio and TV signals at specific frequencies. The problem is that these signals can only come from Grade 0 civilizations. Besides, a lot of signals get lost because they interfere with the static in space. A more effective way would be to break down the signals into all frequencies to preserve most of the information. However, if a Grade 0 civilization only uses a single frequency, they might not be able to read the information completely, and would just hear meaningless noise. So, even if the Milky Way is full of messages from Grade 2 or Grade 3 civilizations, our Grade 0 radio telescopes just can't interpret them correctly. Another researcher from the National Astronomical Observatories of China came up with a new theory about where these civilizations might be hiding. He and his team scanned a large area of the sky and found 21 galaxies. They were looking for unusual radio signals to detect traces of alien civilizations. The team found 2 strange galaxies with enhanced infrared radiation. This could be explained by natural phenomena, but astronomers are hoping that it could point to some Dyson sphere structures, or entire galaxies captured by intelligent civilizations. However, to prove this, they need to know exactly where this infrared radiation is coming from. There's another possibility to explain the Fermi paradox. These civilizations might have chosen to stay hidden. Our universe is so huge that just because we haven't successfully found any life doesn't mean it doesn't exist. When astronomers are looking for signs of technologically advanced civilizations, they usually base it on observations of different types of infrared radiation and waste products. But what if superintelligent civilizations not only have flawless technology, but also found ways to hide themselves? If that's the case, we've been looking in the wrong direction and missing out on what's really worth paying attention to. If we keep failing to find any signs of extraterrestrial civilizations, we can try to study the missing parts. The most likely scenario is that if there's a Grade 3 civilization somewhere, it'll absorb all the energy in the Milky Way and deplete all the energy supplies, leaving empty areas. And there are such voids in space, the cosmic voids. They were once thought to be signs of intelligent life, but this theory has been disproven. Although scientists haven't lost hope, most of the research has hit a dead end. If this keeps happening, another question pops up. What if we were just born at the wrong time? According to a computer simulation, intelligent life might have been more abundant about 4 billion years ago. Not now. It sounds unbelievable. But if primitive life existed on Earth about 3.5 billion years ago, why couldn't intelligent life have emerged in other parts of the universe at the same time? Should we be so eager to satisfy our natural curiosity at the risk of human extinction? After all, we all come from the same ancestors, but we can't even control our anger towards each other. So, would super advanced civilizations care more about our lives than we do today? We're afraid of running out of Earth's resources. A grade 2 civilization would be worried about the death of its star. And a grade 3 civilization would be concerned about how to escape the end of the universe. But according to the expanded version of the Kardashev scale, for grade 4 or even grade 5 civilizations, these things aren't worth worrying about. These beings could theoretically create a new universe. According to a physicist, creating a baby universe in a laboratory would require about 1,000 trillion degrees of energy, which is far below the capability limit of a grade 4 civilization. Although a grade 4 civilization is almost impossible to achieve, it means becoming the creator of everything we can observe, think about, or imagine. Given the speed of human evolution, even today, creating effective mini laser-propelled spacecraft is within our reach. This might mean that we've been visited in the past, but the chances of us noticing their existence are almost zero. Even now, we might be being observed by a more advanced civilization. They're just waiting for us to make enough progress so that we can finally make contact with them. Maybe they've already decided to make contact with us, but it'd take hundreds of thousands of years to travel here from another galaxy. However, even if we don't find anyone, it might not be a bad thing. We might feel lonely or even abandoned, but it also means we have the chance to lay the foundation for the future of human evolution. Someday, those superintelligent beings might look a bit similar to us in appearance. They might think of us as pioneers, explorers who discovered the world in this darkness. Just like a child discovers the world. Maybe it's our imagination that makes us think they exist. Or maybe they really do exist, but they're not someone else. They're the future version of us, the superhumans.